So clearly the magic in business transformations, though, come when you have a complete end-to-end solution. So billions of connected devices, streaming data real time into the analytics engine in the data center, and the opportunities are endless. So I'd like to invite back out my partner, Doug, and he'll come out, and we're going to do a deep dive into one such industry ripe for transformation, healthcare. Hey, Doug.
Hey,
okay, so here in the U.S., I'll let you take control.
Okay.
So here in the U.S., as you may well know, we spend $2.5 trillion every year on healthcare. That's 23% more than any other nation. And sad to say, we don't produce any better outcomes based on that spend.
Right. And you know, by the year 2020, the Internet of Things is expected to have the greatest economic impact in healthcare for those very reasons. So using connected devices to continuously monitor patients while they live oftentimes in their own homes, particularly those that have chronic disease kind of challenges, may really improve the lives of millions of people.
Yeah, exactly. So who better to help us understand the transformation that to the healthcare industry that we can collectively have than our own Eric Dishman. Eric is an Intel fellow, and he leads Intel's health and life science sector, and he's also a member of President Obama's Precision Medicine Health Initiative working group. So for him, advances in healthcare aren't just about business, it's also personal. You're a cancer survivor, we're happy to say.
Thank you, great to
that
see
you
you.
survived, not that you had to endure it.
Yes, no, getting over it was the best part.
Yes, exactly.
So hey, welcome, Eric. You know, maybe you can tell us a little bit about some of the challenges that are really facing the healthcare industry.
I mean, governments and providers around the world are challenged to achieve what healthcare calls the triple aim, namely to improve the cost, quality, and access of healthcare for all of their citizens. And they're beginning to move towards an era of what's called precision health, where analytics has this power to do two huge important breakthroughs. The first is distributed care and personalized care.
So Eric, if we kind of pick that first topic, you know, distributed care, maybe symbolically we think about the edge, right?
We'll go to the edge.
Leave me alone.
We talk about maybe what's happening out in the realm of collecting data. You know, one example we might think of is in the U.S. alone, we spend $10 billion a year on infections that people acquire while they're in the hospital. So maybe think about how could distributed healthcare capabilities help with that challenge?
Well, you know, hospitals are really important places, but they're not the right tool for the job, especially since our studies show that more than 60% of the time, care that's done in a hospital can be done safely and effectively at home. You know, hospitals can be deadly places for an immune-compromised cancer patient going in for chemotherapy. 2 of the 3 times that I was closest to death in all those years of cancer were from hospital-borne infections. So once that happened, I insisted from then on out that I wanted home infusion and home-based remote patient monitoring. But the problem is that there's never been a reliable, secure infrastructure that would really allow us to scale patient care at home.
So maybe let's talk a little bit about what Intel and the rest of the industry are doing to shift care to help address this kind of a problem.
Well, we need easy-to-use solutions, and we need a supportive regulatory environment. On the regulatory side, Intel has been working with governments in Asia and the European Union, and especially in the United States, to help drive reimbursement for home-based care. And we've worked with a lot of standards organizations to make sure that these health monitoring devices and wearables are interoperable, standards-based, and secure.
Right, so on the technology front, you know, we're really excited about the potential where the Internet of Things can help data researchers and doctors see patients maybe in a whole new light and unlock some of the improvements that we think are really possible with care. Now, I talked earlier about how we've created this IoT platform that provides the capability for secure data analytics, manageability, all those kinds of things that are necessary out here on the edge. So the power of an IoT platform can then enable developers across the industry to be able to extract that data from the edge, to be able to analyze it, and then marry it with other data that might be accessible back in the cloud and give us all kinds of new insights.
I mean, a great example of those insights is Intel's support of a patient monitoring trial with Oregon Health and Science University. We've got 450 volunteers who have been outfitted with Intel's Basis Peak Watch and a home wireless blood pressure cuff, wireless scale. It's all going through your trusted IoT home gateway. And, you know, with heart rate, steps, sleep, sweat, blood pressure, and calories burned data all coming in real time. These are generating 3 million data elements per night from just those 450 people.
Wow, wow. So if you think about maybe then some of the other challenges, if you could prevent maybe some cardio type of issues.
If I think back to my own oncology experience, right? If my physicians had been able to detect and prevent the building cardiotoxicity from my chemotherapy that was poisoning my heart slowly, my third near-death experience, by capturing far more data in my home and on my body than the occasional office visit could ever give them.
So now out here on the edge, we can create sensors and we can create gateways to collect and analyze data out here on the edge and securely transfer it in the data center or cloud. But there's lots of data there that we can analyze in new and different kinds of ways. But we're going to need Diane's help for that. So help us out here a bit, Diane.
Okay. Yeah, no, thank you. So let's now talk about the other side, about personalized care. One of the most exciting data types in the healthcare world is genomics data. It is the biggest of the big data. And there's enormous promise in using an individual's genome sequence to actually transform their care. And last year at IDF, with a lot of help from you and your team, I announced our declaration for all-in-one day by 2020. And if you're here, you remember we were working with the industry as a whole, and in one day we were going to enable the sequencing of a whole genome, then identify the fundamental genes that were causing that cancer, and then the means to create a personalized treatment against that gene, and do that all in a single day. And time is clearly of the essence when you're dealing with cancer, and I know, Eric, you know that better than anyone.
All too well. Absolutely. I was trial and error treated for cancer for 23 years before a chance encounter to get a whole genome sequence changed everything. That analytics took 3 months of compute and 4 months of my medical team FedExing terabyte hard drives back and forth coast to coast before I had a new treatment plan that made me cancer-free and healthier now at age 47 than I was when I was 19.
And I've known you for many of those years, so I can attest to that. Yeah. It's transformational.
Absolutely.
Really amazing. And so your experience just underscores this need for all in one day, make it happen faster. And since last IDF, we have been hard at work partnering with OHSU to develop a means for analyzing massive genome data sets. And it is my pleasure, and I'm truly honored and excited to have with us today Dr. Brian Druker. Dr. Druker is internationally recognized oncologist. He's an award-winning researcher. He developed a revolutionary cancer treatment that attacks the molecular cause of the cancer without damaging the healthy cells. And I'm just honored to have him. Dr. Druker, please join us. Hi, hello.
Great
Thanks
to
for
see you.
joining. Yeah,
Good to see you.
Thanks for being here.
We can all agree that it shouldn't have taken 23 years to develop a personalized treatment for Eric. We should be able to do this in one day. But the reality is, Eric's story isn't unusual. In the profession today, we still treat patients with this one-size-fits-all approach, but we know that we each have a unique genetic makeup and our diseases have a unique genetic profile. But as an example, we treat 2 patients with the same advanced cancer with the same treatment. One lives and one dies. And we don't understand why. And even worse, this data is siloed in our institutions. If we're going to achieve all in a day by 2020, we need a collaboration breakthrough.
Yeah, it's a very good point, Dr. Drucker, and I'd be interested to explain why is it that all the data is so siloed? Why do each of the hospitals and research institutes hold their data so closely?
Well, first of all, genomic data is just simply too big, and it's distributed across the entire world, sitting in large cancer centers. And the other problem is cancer centers are hesitant to share their data because of security concerns. Now, even for the lucky 2% like Eric that get their genome sequenced, we can't quickly get to a personalized treatment. It requires phone calls, data being faxed, emails going back and across the country. That's the experience and the challenge that I face every single day when I'm trying to save my patients with advanced cancer's lives.
Amazingly manual, considering where we are in the state of technology. It's really is unfortunate. So this is exactly the problem then that Intel and OHSU set out to tackle after IDF last year, and we're really happy to say today that we have brought up the first collaborative cancer cloud. The Collaborative Cancer Cloud, if I can give a little bit of technical detail, it's a platform that is distributed. It distributes the analytics across multiple data sets, across multiple organizations and institutions that are hosting those data sets, and we do it in a secure manner. It uses the Discovery Peak platform that I talked about earlier to build the queries and the analytics. And it uses Intel's trusted execution technology that's embedded in our Xeon processors to create secure virtual machines. And those secure virtual machines then hold the results of the query across those different institutions. And when the data query is complete, the virtual machine is removed and all traces of the data is eliminated.
Right, Diane, with these technologies, we've already proven it's possible to connect other institutions in a proof of concept. The next step is we need to make this a reality. So I'm happy to announce that by Q1 of 2016, we'll have extended this collaboration to 2 other large cancer centers, enabling all 3 institutions to securely share large amounts of real-world patient data. And beyond that phase, we hope to open this up to dozens of collaborating institutions. Now, we've chosen Intel as a partner in our quest to cure cancer due to their unique ability to create an expansive ecosystem around a common, open platform like CCC.
Yeah, and thank you for choosing us as your partner, because we certainly do believe we are off to a great start here.
I mean, to that end of openness, I'd also like to announce that Intel will open source components of the Collaborative Cancer Cloud starting in the first quarter of 2016. This will make it faster, easier, and more affordable for developers, researchers, and clinicians to go after cancer together. We need your help to drive the interoperable exchange of genomic information and to speed up the analytics of genomics and personal health analytics. And by supporting the work of the Global Alliance for Genomic Health, you can help to start and speed up creation of standard, reproducible pipelines that float all boats for everybody.
And given the fact that half of all men and a third of all women worldwide will get cancer in their lifetime, it's clearly a priority for all of us. And the good news is, Dr. Drucker, that when we develop this collaborative cloud, distributed analytics cloud, it's not just for cancer.
No, that's absolutely right. Cancer will be first, but we recognize that any disease driven by genomics, and that's pretty much every disease, will be applicable to this. So imagine a collaborative Alzheimer's cloud or a collaborative cardio cloud. That's where we're headed.
Yeah, it's amazing.
So, hey, I want to thank both of you for giving us a peek into the amazing transformations that are happening here in the health sector. So, please join me in a round of applause for Eric and Dr.
It's really impressive. Thank you. Thank you.
Great to see you.
Yeah.
Thank you so much.
Thanks.